a little bit about the sum. For an alternating series that converges, not just any alternating series, but one that converges, we can get a pretty good estimate of the sum. In fact, we can get as close as we need to the sum S by adding enough terms of the series. And this would be the alternating series estimation theorem. Let's see, I'm going to say this about it. So notice that when we add another term, to the partial sum, we are closing in on S. So we're going to call this, so the error, let's say it like this. So if we have partial sum S sub n and S is the exact sum, then we can find the error between the two. And it would be this: S minus S sub n. S minus S sub n. And actually, instead of calling that the error, we'll call it the remainder. So which we call the remainder. The remainder R sub n. So we have this. R sub n is S minus S sub n. So the estimation theorem tells us that this remainder is going to be smaller than the next term. So the alternating series estimation theorem is this: if the sum S equals the sum from as we sum up -1 to the n minus 1 times b sub n, if that is the sum of the alternating series, and we have the two conditions met, so it converges. I'll just put and this series converges. The book gave the two conditions, but if you have those two conditions, well, it converges. Yes, there. Then we have this. The remainder The absolute value of the remainder R sub n is the absolute value of S minus S sub n, and that's smaller than or equal to the next term I would add or subtract, B sub n plus 1.